Chapter 5 States of Matter. There are three states of matter: gas, liquid, and solid. Gas molecules are far apart and fill the available space. And liquid molecules are close together but move relative to each other. And lastly, solid molecules are tightly packed in a regular array and move very little relative to each other. Five point one. Gas. General properties of gas: compressible, low density, diffuses quickly, fills up a container uniformly, and exerts pressure uniformly on all sides of a container independently of the height of depth. An ideal gas is a simplistic model that describes how molecules or atoms behave at the microscopic level. It is used to determine the relationship of temperature, volume, pressure, and quantity in a gaseous system. An ideal gas behaves precisely according to the kinetic molecular theory. Kinetic molecular theory of gases. The behavior of an ideal gas has four basic assumptions of an ideal gas. First, the volume of gas molecule is negligible. Gas molecules consist of tiny molecules and occupy no space at all. Second, the intermolecular forces between the molecule is negligible because gas molecules are far apart from each other. The third one, when molecules collide, the collision is elastic. That means no loss in kinetic energy and molecules do not stick together. Lastly, number 4, average kinetic energy of the gas molecule is proportional to the temperature of the gas, where kinetic energy is directly proportional to the absolute temperature. This can be explained by Maxwell-Boltzmann distribution. The first law of gases that we're going to study is Boyle's law. It is discovered by Robert Boyle in 1662. It states that for a fixed amount of gas at a constant temperature, gas volume is inversely proportional to the gas pressure. Mathematically, it's expressed as volume inversely proportional to the pressure at constant number of mole and absolute. For a given sample of gas at different pressure and volume, initial pressure and initial volume will equal to final pressure and final volume. In practice, real gas does not obey Boyle's law perfectly because under high pressure, gases do not behave ideally and would liquefy because its volume is reduced to zero. These are the graphs which involve pressure and volume. The first graph, pressure versus volume, you will get inversely proportional. And then pressure and volume versus pressure, the graph will be horizontal straight line. And pressure versus 1 over volume, the graph will be positive slope straight line. The given questions is the example of the Boyle's law application. Second gas law, known as Chasles law, is discovered by Jacques Charles in 1787. It states that for a fixed amount of gas at a constant pressure, The gas volume is directly proportional to the temperature in Kelvin, mathematically expressed as volume directly proportional to the absolute temperature at constant number of mole and pressure. For a given sample of gas at different temperature and volume, initial volume over initial temperature will be equal to the final volume over final temperature. Please remember that temperature in Kelvin, when you were to convert, you must add temperature in degrees Celsius plus 273.15. This is the example of question that are using Charles' law. In this question, they ask you to calculate the final volume. The formula used is volume initial divided by initial temperature will equal to the final volume divided by final temperature. Please bear in your mind that all the temperature using in this gas law must use absolute temperature. The third gas law is Avogadros Law. It is covered by Emilio Avogadro in 1787. It states that at constant pressure and temperature, the volume of a gas is directly proportional to the number of moles of the gas present, mathematically expressed as volume directly proportional to the number of moles at constant pressure and temperature, or volume divided by number of mole will become constant. So that for a given sample of gas at different moles and volume, initial volume over initial number of mole will equal to the final volume divided by final number of mole. Ideal gas law. Ideal gas law obey all the gases law, which are Boyle's, Charles' and Avogadros law. If Boyle's law, Charles' law and Avogadros law are combined, a single expression relating P, V, N and T is obtained. This expression is known as the ideal gas law, where volumes is directly proportional to the number of mole and absolute temperature and inversely proportional to the pressure. So after we derive, the final equations for ideal gas is PV equal to nRT. The ideal gas is PV equal to nRT. What is R? R is a gas constant. There are two commonly used gas constant value. The first one is 8.314 joule per Kelvin per mole, and another one is 0.08206 liter atmosphere per Kelvin per mole. And please remember, gas which obey gas laws and ideal gas equation under all conditions known as ideal gas. And for a calculation purpose, all the pressure, volume, gas constant and temperature must be in the correct unit. This is the units for pressure, volume, universal gas constant and temperature. 8.314 and 0.08206 are the unit for the gas. This is the example of question that relate with the ideal gas equation. The equations used here is PV equal to nRT.